All right. Very last question, question number 10. And this says, match the following equations with its correct answer. Now, I was trying to be super nice and actually keep these all pretty much in y equals. If you notice, the top one is in y equals and the bottom one is y equals. So if you actually go ahead and graph them both, if you graph the top one, you're going to see two lines that are parallel. How do I know that they're parallel immediately? Well, they got the same slope. How do I know that they're not infinite solutions and on top of each other? Well, they have different y-intercepts. Since they're parallel, these are both no solution. Okay, they don't equal each other. And if you want to do it mathematically, you totally could. You could do 2x minus 1 equals 2x plus 3 because they both equal y. 2x plus 3. And actually, when you get rid of the 2x, and you see that happens here where they both cancel out, we say negative 1 does not equal 3. It does not equal. So since they don't equal each other, since it's impossible for that to happen, that is why this is a no solution. So I would drag no solution up here to the top because that is a no solution question. The bottom question, where you have two totally different lines, this is going to be a one solution type situation. Again, if you graph it, you will notice that they intersect at a specific point. That is when you have a one solution where they actually touch in one place. If you don't have time to graph it or you couldn't graph it, another option that you could have done is, again, since they both equal y, they both equal each other, and seeing what happens when you work it out. So you would have 3x plus 6 actually equal to 2x plus 3. Okay, when you try to get the x's the same and we try to get the numbers the same, that cancels out, we end up getting x equals negative 3. That's a solution. Like that gives me a straight up answer. X is negative 3. And since it gives me one answer, that is a one solution. So that's why that one goes with one solution. So I would go ahead and drag one solution down here to the bottom because those two match. Now that leaves the very last question to ponder about. Why is number 2 infinite solution? Well, if you notice, y equals 5x plus 2 has a lot in common with the bottom line. If you multiply the top line by 3, you will actually end up seeing the exact same line up there in the bottom. Or if you divide the bottom line by 3, you'll see the same top one. So we're going to go ahead and try that. We're going to just zoom out here so I can use some other type of space. And we're going to say y equals 5x plus 2. And we want to multiply this entire equation by 3. Okay, multiply the whole thing by 3. That would give us 3y equals, that multiplies by that. This one multiply this one would give us 15x. And then this multiplies by this plus 6. Let's look back at our original equation. That's exactly what I have written here. And that is why, since these are identical lines, they are the exact same line, this is an infinite solution. Because no matter what number I put into x, I will get the same y. So if I plug in 2 into x, let's try it. 2 times 5 is 10 plus 2 is 12. Y is 12. Okay, if I try that on the bottom down equation, 15 times 2 is 30, plus 6 is 36. 3y equals 36. Divide by 3, you get 12. So same exact numbers. You get the same numbers in the top and bottom, and that is why that is an infinite solution.